Resume recording. Okay, so we're going to go over dictionaries. A dictionary is a collection of values. However, there's something different, because if you remember lists and tuples, those are also collections of values. Do you remember what makes a dictionary a little different? Okay, yes. I'm reading the chat, by the way, guys. There you go. Perfect. So there are keys and then there are values. So it's actually called a key-value pair. So if you look right here, here's an example of what a dictionary looks like. Here's the name of the dictionary that we're naming it. And here, you'll notice that the dictionary has the little mustache. I assume this is what you mean. Mustaches. You have a curly brace on the outside, and you have a curly brace on the other side. But on the inside, here's where the key value pairs come in. Thank you, Lisa. Right there. So this first part of what I have highlighted is called the key. It identifies, it's basically sort of like categorizing what's coming next. Then you throw a colon after it, and then you say whatever the value is for that key. So exactly, Danielle, we do have values. You'll notice we have a collection of them sitting in this dictionary. So for this cat, he has a size, a color, and a disposition. But more specifically, the value for the size, the color, and the disposition is what comes after the colon. So he's fat, gray, and loud. So in order to do a dictionary, always remember you have two parts. You have the key and you have the value. And I loved Bethany's analogy last week, which actually totally makes sense because a dictionary is a dictionary, right? You use a dictionary, you think of the word you want to look up, like anti-disestablishmentarianism, or however you pronounce that.
I can't believe you got that all out of your mouth. Wow.
I don't think it was said right at all. But that's the key, right? You look that word up. And when you go in there, you see a definition. That's the value. Okay, so you have a lookup, and then you have the value. So this entire conversation for Chapter 5 is about dictionaries. So keeping that in mind, if I want to, back to my original question was, what does the code for an empty dictionary look like? So I'm going to go ahead and start it off and call it an empty dictionary because typically you assign a dictionary to a name. Okay, so we're going to call it an empty dictionary. And what should I put next?
And so you have two ways that you can do this. You can call you can do what's called calling the constructor, or you can use the literals, which was my mustache hint.
Perfect. Okay, so what we're going to do is let's start with the literals. Lisa's given us a hint. We're going to use curly braces. So we're going to start it off like this. Uh-oh, why is it not typing? I'm in the wrong screen.
Uh-oh, is your mouse giving you the finger?
There we go.
Cool.
There we go.
Behave.
So we have our open parentheses, open curly brace and our closed curly brace. And that's it. Empty dictionary. Nothing's inside of it. We have no keys or value pairs sitting inside of it. Okay, our next question. Does anyone have any questions about that one? Ooh, let's do answer to question 1. You mentioned, Bethany, that we could have used a constructor instead. So if I remember correctly, constructors are similar to saying something like this. This is a string, like convert this to a string.
Yeah, so that's a function, and that function
Okay.
basically takes whatever you put in the parentheses and converts it to that type of thing. So
is that what you meant when you said constructor, though? I just want to make sure I'm okay.
Yes, that is exactly what I meant. And constructor is the generic term we use for things like this. So there's a string one, there's a list one, there's a tuple one, and as you might imagine, there's one for dictionary.
Okay, so if we tried it again, the literal is literally doing the curly braces. That's what she meant when she said literal. But if we did it as a constructor, my guess, and that is what this is a guess, is something like that.
That's absolutely perfect. And you got it right. So for a lot of these, right, list is list, but dictionary, I guess, was deemed too big to use, so they used dict.
Okay.
Instead of dictionary, yeah.
So we could have written it either way. And I just happen to, I do this part here just because when you're writing the code, you're about to use it, so I just normally assign it to something. But that's the way of creating a list, a dictionary as a constructor, and this one as a literal. Okay, let's try question number 2. Question number 2 says, cool. The question number 2 says, what does a dictionary value with the key foo and a value 42 look like? And we have some feedback from Lisa. Looks a little bit like this. Okay, this is technically not an empty dictionary anymore, but you get the point. Here's the dictionary part, where foo is the key. It's the part before the colon. And the value is 42 after the colon. Now, because I copied and pasted this somewhere, I'm going to change these little single quotes to make sure they work okay. I don't know if y'all noticed, they sort of were curled in, and that actually is a different type of quote than this one. And I've noticed my code like throws errors if I still have that curly version of the single quote.
Yeah, those are called smart quotes, and they're kind of the bane of programmers everywhere, because underneath the covers in the land of zeros and ones and codes, your computer sees those curly ones as a different Unicode character code from the flat ones, which your computer recognizes and Python recognizes as, quote, single quotes. And so, yeah.
So worst case, if it looks curly, change it. Just
yep.
make sure they're nice and straight like that.
And if your code editor is turning a funky color and you look at that and you're like, that doesn't look like the color strings normally are, chances are good.
Gotta fix it.
The curly quote has gotten you.
Yeah. So here, let me do that again just to make sure if anyone had any questions about what we're talking about, you can see the difference between these two. Because if you notice, Python is lighting up very specific keywords. So you see how this is a different color than this? I automatically knew something was a little fishy here. And if you notice, see how that's curly and that's straight? That's what we mean by changing it. So all I did was backspace these guys out and just went back and put in my single quotes again, which is basically to the left of your return key. Okay, now, thank you, Lisa, for that answer. I do have one thing that I want to change. Please correct me if you think I'm wrong on this one. The question asked for a value 42 look like. Now, it didn't necessarily specify whether or not it was a string or an integer, but to me, what this says is we are taking the key foo and assigning the string 42 to it. If you want to assign the integer 42, we have to take off those single quotes, correct? I think that's the way we need to do it. So it just depends on what your need is going forward. Awesome. Cool, I got a yes from the crowd. Thank you, Angelica. So this is assigning an integer to foo, while this is assigning a string to foo. So just keep that in mind. Those are two different things. Okay, let's answer question number 3. Question 3 says, what is the main difference between a dictionary and a list? And
yes and no, Danielle. That is probably the answer. Just to let everyone know, Danielle said lists are ordered, dictionaries are unordered. As of Python 3.7, dictionaries are ordered, guaranteed, the order that you add things in. But that's probably the answer that the author of this book was expecting, because he wrote it before that was true. But there's another really big difference between lists and dictionaries, and it's how you get at the information. Does anyone know what that is?
Let's see. So the question, Lisa came back with key value pairs. So dictionaries is one of the things that we talked about right at the beginning, was that a dictionary has a key value pair. So we see that it has the key and the pair. I mean, excuse me, we have a key and a value. So let's say if I take that, there's my example of a dictionary. Correct. All keys, they're special in that they're unique inside of the dictionary. But here's an example of a list. If I can remember my lists right. So if you see here, this first one is our dictionary, the second one is our list. This has one key value pair in it, while this has 3 items in this list. Notice this has curly braces, this one has square brackets, and we don't have like a 2-parter when it comes to the item. For the dictionary, it comes in 2 parts, a key and a value. Here, it is just a value. So here, this 42, it's just one value. Here's another one and another one. So if I wanted to make 3 items in my dictionary, I'd say something like this. Okay, so they both have 3 items, but this one is made up of a pair of things, while this one has its own individual. That one's square brackets, that's curly brackets. And Bethany?
And if I want the first item of the example list, what do I do? If I want to get at 42 in that example list.
So if I want to access a portion of the list, how would we go about doing that?
The list, not the dictionary, but good thought, Lisa, because I was going to ask that next. Yes.
Perfect. So if we wanted to access the list, we would do something like that, where 0 means the position or the index in that list. So if I want to access 42, I'd say at position 0, give me that value. But if I want to do in the dictionary,
So Lisa had the right answer there. What's the key to unlock the number?
Yeah. So if we did, okay, if we just did key like this, correct me if I'm wrong, but I believe what this will do was it will give me all of the keys.
Yeah, I think I think there's an S on keys. Yeah, I think there's an S there. Let me look that up. Just, you know me, sometimes I misquote the docs, which is terrible.
Actually, if we go back here, it should be somewhere in here.
Yeah, it's dix.keys, Keys.
Okay, so if we use .keys like that, notice how here it prints out. Oh, here it is. Here it prints out all of the keys. So here's our dictionary for spam. Color, red. Age is 42. And remember, the keys are the first part of the key value pair. So when you use .keys, what you're returning is color and age. So .keys will give me a list-like value of all of the keys in the dictionary. Here we go. Dict.key, where it's
close, Angelica, but what you don't need key in there. So you just need the name of the key in the brackets. Like so that. This is just to point out that a list you access by index number or order, and dictionary you access by key, by name, right? By lookup value. You can access a dictionary these days by order, but it's considerably more kludgy than just going after it. If you know what you want is the value that foo belongs to, then you ask for the value at foo. So that's one of the big, right? The big differences is with dictionary, you look it up by name. With list, you look it up by order or by index number.
So we had to use that key there to get in there. So that's, yeah, okay.
Yeah, and so that same thing goes for assigning a new value. If you want to assign a new value to the thing at index number 1 on the list, you would do what?
Okay, so changing the question to for index number 1 in the list.
Well, or index 0 in the list. Let's just keep with the same index 0. So okay. If I wanted index 0 to be 32 instead of 42,
okay,
what could I do? So it's the same thing as looking it up, but yep.
Perfect.
Perfect.
So I just basically take what I just had and add an assignment operator. I like it.
And then the same thing goes for the dictionary too.
So something similar like that. Cool. Okay, our next question.
All right. Question 4.
Uh-oh, I lost the questions. I don't know where they are.
Oh no!
Oh, that's right. I was looking on my other computer. What happens if you try to access spam foo? Here, let's look at it here so that you can see what we're trying to do here. What happens if you try to access spam foo if spam is bar 100?
Ah.
Cool.
So another way to phrase this question, to use the same metaphor we just practiced, what happens if I try to get at a 4th item on our example list? It's similar to what happens when you try to get at foo.
I love
the dictionary.
I love Lisa's answer there. You're getting an error message.
Yep. And so for the dictionary, it's a key error message because you're looking it up by key. And for the list, it would be an index error message because there isn't anything at that index. But again, analogous error, Python's going to be like, okay, it may be in your head, but it isn't in my records. I don't know anything about that.
So if you notice, here's your dictionary. You only have one key value pair in it, and its key is bar. You're over here trying to look up foo, which is not in this dictionary. So that's why you get a key error message. Love it. Okay, next question. Question 5 is, if a dictionary is stored in spam, what is the difference between the expression cat in spam and cat in spam keys?
Oh.
If a dictionary is stored in spam, what is the difference between the expressions cat in spam and cat in spam keys?
So the hint here is stored in. So what does it mean to store a value in a dictionary? So in the dictionary on line 11, oh, that one might be a little confusing. We might want to make a new one. But think about that for a minute. If I'm putting a new value into the dictionary, storing it in the dictionary, what does that mean?
Well, a value can't be added unless you have a key.
Mm-hmm. And so there are keys and there are values. So what does the in check for?
Say that again. What does the what check for?
In check. So let's just actually it's probably better to see a real example. Let's put together a dictionary with 3 keys.
Okay.
Let's say pet, food, and I don't know, toy. We'll make the pet a cat. Dance feast. Just remember to make all those, yep, strings. Perfect. Okay, so if we check to see if cat is in new dictionary, what are we going to get back?
Well, not found because it's looking for cat as key.
Let me see.
Oh, is this what you're asking? If we look for cat like that, we're going to have that key error again?
That will return with an error.
I agree with that because the cat is not a key. Pet is the key. So what is the difference between the expressions dot cat and spam? Oops, I was supposed to call this spam. Sorry, guys. Threw it off. What is the difference between the expressions cat and spam and cat and spam keys?
Can we try just typing cat in spam and see what it says?
No, that's too simple. I'm trying to remember how to, is it, how do I do a block comment again in Python?
block comment, 3 double quotes or 3 single quotes at the top of the block and 3 at the bottom.
Gotcha. Thank you.
Welcome. Ah, yeah. So this might be a little bit of a trick question.
Okay, so we have a dictionary that's defined. If I print just the value of cat, I mean, trying to find the key of cat, we already know that's going to error out. We just discussed that. But if we're trying to print cat in spam, did I get that right? Is that what we're literally trying to do?
Mm-hmm. But you need it to be a string. Yeah, because you stored it as a string. Yeah.
Oh, that's right. In is that it's that value, not value. It's a condition check. Is this in it?
Right. But you know what's interesting about this is, because I just tried this in the editor, I fell for this. I was about to say one returns true and the other one doesn't, but they both return false because they're doing a
search for a key.
A key search. Yep. So if you change it, if you go back and put pet in spam, then you might get a different answer. Yep.
Hold on, let me just make sure everyone sees what you're talking about. Okay, so, well, see, when I did that print for spam of cat, it does throw an error. It doesn't.
It throws a key error because there it's doing an explicit lookup. But if you do an in check, in returns true or false, a Boolean, and it will give you a false instead of an error.
I agree with that. I thought that you said, though, I guess I misunderstood what you were saying earlier.
I was saying if you change it from is cat in spam to is pet in spam.
Oh, gotcha.
Yeah. And if you change it from the value to the key,
we'll just focus on the one. Wait, what? What did I do wrong now? You just fixed this error. Yes, I know. Continue. Okay, so now it's true. It did find pet inside of spam because it's sitting right there.
Yeah.
Now, tell me, this is something I might have missed. I don't need this print if I'm just doing this value assessment, right?
It may be different in Python Tutor. If you're doing this in the terminal, it'll give you an answer, but it may not give you an answer in Python Tutor because it might swallow the output because of the way it's evaluating. Okay. So I just wrap it in a print to be safe.
Okay.
Yeah.
Sounds good to me. Okay.
So this one is a little bit of a gotcha because when you do an in check for a list, you don't say, is there a thing at index blah? You say, is blah in the list? But for a dictionary, it's a little bit different. For a dictionary, if you're doing an in check, it's going to look it up by the key and not the value. In a list, it looks like the in check is looking it up by value, but in a dictionary, it's looking it up by key. So.
And thanks, guys, in the chat. Forgot to acknowledge the help.
Hey.
Okay, let's go on to question 6. Good stuff going on here. If a dictionary, how about I put this in here so people can read it? That'd be great, Jamila. Let's see. And okay, so if a dictionary is stored in spam, what is the difference between the expressions cat in spam, cat in spam values? So very similar, but the big deal here is this word here called value. That's what makes this question different.
Right, and also dot keys, dot values, what do they return? They return
List, or a list like
yeah,
value of everything in here. So if we did a spam dot keys on this guy, it should have been a list of pet, food, toy.
yep.
So keeping that in mind for this one, I won't spoil it. I'll let someone else answer this one. What's the difference between cat in spam and cat in spam values?
Well, just to give a little nudge, we did establish what cat and spam does just a moment ago.
Yes. Well, for this guy here that I have, cat looks like it's a value to me. So for what we have defined here, what is the difference between cat in spam? So I think that first piece, agreed. So cat in spam only works for a key. And so in this case, since cat is not a key, it is a value, we're going to have a problem with that.
Right.
But, so if we did cat in spam values, would we have a problem with that?
We shouldn't, because values returns a list of all the values, and I think that does include a cat that likes Fancy Feast, yes? Which is my cat unless he's being picky, which he often is, but you know.
Let's see what happens. So it's cat in spam values. So like we said before, dot keys returns all the keys, dot values returns cat, Fancy Feast, string. So it should, if I wrote this right, return a true when we do this one. Oh, come on now. Oh, that's right. Sorry. Okay, let's try that again. True.
Yay.
It found our cat. False for the first one and true for the second one. Correct, Angelica. I agree with you. High five. What is the shortcut for the following code? Ooh.
Color not in spam. Oh, you know what? I always have to look this one up because I just don't do this very often.
Okay. What is the, ooh, okay. What is the shortcut for the following code? So if we just walk through what the code is saying, if the color is not in spam, then go to spam, go to color, and add the string black. So basically what you're saying is spam being a dictionary, add this key, and for that key, add a value. So the shortcut for that, Lisa is giving us set default.
Yes.
So
because if you don't do that, then Python's going to be like, well, I couldn't find anything named color. I don't know what you're talking about.
I'm trying. winging this. That's right. Spam.setDefaults. So if you add the key that you want to add if it's not there, and then the value that it should be if it's not there. I believe.
Yeah, I think so. I'm going to look it up. Like I said, I always have to look it up.
Let's see,
this is one of those things that I just won't stick in my head.
So like this. Spam.setDefaults. There's your first value, and there's black. Wait a second. That's the exact question they just asked us. That is the answer. Okay, perfect.
Nice. Well, it's important to, you know, it's at every level, no matter how often you use the language, it's important to kind of go back through things because you can't possibly hold all of this in your head. So it's always great to review. Always.
But I think the key on that one is, even once again, like you said, it does not matter how expert you get, as long as you have an idea of what you need to find.
Yep.
Then you can look for it. So we had an idea, set default, how it's written, that's a completely different story. So we know what we're searching for. So
this is why no professional programming gets done these days without Stack Overflow.
Oh, I get it. Google Stack Overflow becomes your best friend for sure. Okay, we got one more question to review. Oh, and I'm pretty sure this was everybody's favorite topic of discussion last time.
Oh, yeah.
Variable and function can be used to pretty print dictionary values.
I'm going to have to cheat and look up at the text. I have no idea anymore.
Isn't it the Pprint?
Ooh, there we go. Okay, so I did the same thing. In my head, I was like, PP, that's all I remember. But it looks like we got some people who definitely remember. Pprint, okay. Now let's see. Let's take this spam. Let's redeclare that. And then if we do a spam.ppprint, wait. We have to import it, don't we?
Yep, because it's a module.
So it's called pprint.
Yep.
Import pprint. So then we go to spam.pprint, and then we do the pprint.
P format, right?
Well, this is the same as.
Pprint's one method, I think, and then the other one is.
Well, you have to add
the other one
first, right? Module and then the function?
Yep.
And then we throw in spam?
Yes.
We're piecing this together. Teamwork, man. Let me tell you. See what happens.
This is why all of us are smarter than one of us.
Yay.
Especially when it comes to me. The group is smarter than I am.
Did not pprint at all. So.
Yay. No?
No.
What?
It printed. It didn't pprint. Because if I remember correctly, isn't pprint where it like puts it all on top of each other, all nice and.
Ought to.
So that must be what Danielle is referring to when she says p format. We need p format to help us out.
But the book is saying pprint.pprint.
I was trying to go off memory, but if we must, we must. Let's see. That's what I thought.
Hey, maybe it's because you resized the window and so it thought it could fit it on one line? I don't understand.
We did this last week and it worked. I remember.
It's gremlins. It is definitely gremlins.
It can't be my code. No, not at all.
Your code looks an awful lot like the code from the book. I wonder if it just needs more stuff in it. Shouldn't though, should it?
Can we try something?
Yeah.
So instead of doing import pprint, do from pprint import pprint, and then just remove
Aha.
and
Yeah,
see.
just import the single method and see if that helps.
Yeah.
Wait, hold up. I didn't catch that. So I say from?
Yep. Do from pprint,
Got it.
then import pprint on the very end. Oh, towards the very end. Yep. Import pprint, and then remove the first pprint on that. I don't think it's gonna do much, but I did this morning actually. It should work.
Did I write it the way you wanted?
Yeah, and it's still not doing it. Why?
I think it has to do with the length of it, or maybe it's just freaking broken.
No.
Let's try, you know what? Let's try P format instead. Ooh, sorry about that.
And the way
Bless
we
you.
do that one is pprint. Oh my gosh, this nonsense. Okay. Do.
That might not work. You might need to put like a comma and then P format, and then remove the first P print on the very front. Oh, on the statement on line 55, do from P print import P format.
Oh yeah, P format. Sorry.
Yeah. And then remove in line 59 where it says P print dot. And then yeah, just remove that, and that should do it.
It hates me.
Oh wait, one other thing we have to consider too. What version of Python is this running? I don't know if this is
3.6.
supported. Oh,
It says it's running 3.6.
is 3.6 on is pprint on 3.6? I don't remember.
It should be. We did this in Python Tutor last week and got this to work, which is what is making this so incredibly confusing.
Let me actually sit up and try to figure this out too.
Okay. So it looks as though, and maybe I'm wrong about this, but it looks as though length of the dictionary matters. So for small dictionaries, pprint doesn't appear to do this. Let me paste something into chat. I was just screwing around with Python Tutor, and this is what uh-oh. Now it's not letting me.
Hold on.
You know what, let me, I'll put it in Slack.
Well, I think I've found, nope, crap. That's a terrible idea.
It's a terrible idea.
Well, actually, it should work because we'll do this.
Yeah, so a long dictionary, I don't know what the long.
There we go.
Yeah. So I don't know what the cutoff is. We'd probably we'd have to look at the pprint code, but it might.
I think I found something. 1 second.
And if we use this guy, I'm going to use yours now, Bethany.
Yeah, so I added like
all nice and flat.
5 items out there. Yeah.
There we go. And now let's try that again. There we go.
Yeah, but also you don't have to use P format. Pprint will work on that too. If you do pprint.pprint, I think it has to do with how wide, right? How much space the dictionary is taking up, right? Okay, so on line 55 though, after P format, put a comma. So you can do P format, comma, pprint. Yeah.
Keep trying to save it. Okay.
And then, whoop.
I'm sure I did something wrong. Let's see.
No, I probably did something wrong.
You gotta remove the extra pprint on line 59.
Because we're importing it.
Yep.
Oh, yeah. Okay. My bad.
There we go.
Whoop. Okay.
So length does matter for pre-printing. That's what we're covering.
Actually, so I pulled up a Stack Overflow article.
Yeah.
So in a way it does. According to the article, the documentation for pprint will try to make it in one line, but if it cannot, it'll make it like we're seeing here.
Oh.
So in order for us to do it, so let's say we have the original 3.
Yeah.
Right? Food equals fancy, pet is equal cat. In order for that to happen, so instead of just doing pprint spam, do pprint spam comma width is equal to 1.
Oh, nice. So you can set it. That's brilliant.
I think that's, yeah, according to the article, that's what it says.
Where width means one value?
One column, maybe?
One column.
Mm-hmm.
How does it figure out?
I think it has to do with, so when you fire up a machine or an editor, there's a configuration about like how many characters wide the view is, and the characters are of course set by like the default system font, and there's all this other rigmarole, but it may be that it's using like an OS or default display definition of what quote column means, like how many characters that is, or how many, like what a default width is.
Do you see what it did?
Yeah, it looks like it did just in one column.
So that fancy feaster broke it up into 2 rows.
Interesting.
I wonder, okay, hold on.
So if you make the window bigger, okay, go ahead.
Okay, let's do that thing you just said while it's still fresh.
Nope, it won't. Okay, so it's actually putting characters in there. So you were saying you wonder what?
I wonder if, let's see, if it has to do with that space.
Oh, yeah. If you put an underscore in Fancy Feast, is it going to break it?
I take it back. One wouldn't mean one column. It looks like characters.
Oh, it is characters. Okay. So if we put an underscore in Fancy Feast, I wonder if it's going to force it.
So I made cat test that underscore just because. So it kept it all on one line. But if you notice, Fancy Feast had the space in it. String test had the space in it.
So maybe that's quote unquote word or yeah.
It's delimiting itself, I guess, every time it sees a space.
Yeah. Yeah. Interesting.
Fancy. Okay. You're definitely going down a rabbit hole. You've learned all you ever want to know about pprint today. Let's leave that at that.
You are all now pprint ninjas, courtesy of Kevin and the rest of us. Go forth and enjoy your certification.
Too, actually, I'm more curious, but I think we're digressing.
Yeah, tiny bit. Okay, so that was basically a review. That was a total review of like the last week, and this week we didn't learn too much new stuff, like new functions or data structures or anything like that. But what we're doing is we're applying it in interesting ways. So the rest of chapter 5 was about basically being able to model real world things. So if you wanted to model a chessboard, for example, it was reviewing the way we need to actually set up our data so that we can do that. And it helped us realize that a dictionary is a very good way of using that with the tic-tac-toe board example. So if you can visualize a tic-tac-toe board in these quadrants, which we're all very familiar with tic-tac-toe, but the key here is for each element of the tic-tac-toe board, giving it a name, or in dictionary terms, a key. And we referred to that key to identify where on the tic-tac-toe board we're going to place an X or an O. So here's an example of how you set up the board. Notice it's just a very simple dictionary. We got our little curly braces on the outside. And the way they actually wrote this, you could have written this all on one straight line. But to make it more human readable and so that it meshes a little bit more with the way that we understand tic-tac-toe, they created a new line every single time you went to the next row on the physical tic-tac-toe. So you have top left, top middle, top right to correspond with those 3 positions in the tic-tac-toe board. So they did that for top, middle, and right. Now when they were defining this board, you'll notice that the value for each one is empty. So they're just starting off with a nice blank, clean board. But when you start adding positions, you change the value to an X or a 0. Here's an example of sort of a game in progress. You still have the top, left, middle, and lower edges all still there, but now you've applied values in very specific positions. So if we want to look at the code for a very specific tic-tac-toe board, here we go. Here, would anyone, I can walk through the code here and sort of explain what's going on here, but does anyone want to talk through it themselves? Just leaving it open to the group. And you don't have to know what's going on. You can sort of just talk your ideas out as you go along if you want.
Go, Kevin.
Okay, I'm gonna do it if nobody else wants to.
I'll give it a try. What
Give it a
line?
try.
What line are we starting at? The very
Let's
first one.
start at the top and see if you can see what it's doing.
Okay, so the line 1 defines the board, what you just went through. Line 5 is the function that prints out the board, and you can see line by line starting with 6. That's the first row with the first row left, middle, and right cells. Line 7 is the dividing line, and then so forth, right? Line 8 is middle row. Line 9 is dividing line. Line 10 is the last row.
So basically, it's like actually printing out the physical board.
The actual board, yeah. And so, yeah, because it's a function, we can call this function to redraw as we update the dictionary on line 1. So then line 12 assigns whose turn it is. So it's X's turn. And then because there are only a possible nine possible cells, we're going to iterate through them on line 14 for I in range 9. And as we remember, for range, it's going to iterate from 0 to 8. And then we're going to do everything under that. So 16 prints the board. 17 asks, oh no, okay.
Before you go too far, why do you think it's stopping at 9?
Well, it stops before 9, right? The definition of what range does.
Mm-hmm.
I thought it was 0 to 8 is what it would iterate through.
But okay,
right, so it's 9 ticks. It's 9 ticks, but it's exclusive of the last number. So 0, 1, 2, 3, 4, 5, 6, 7, 8 is actually 9 cycles.
Yeah.
So I guess my question is, for someone trying to understand this code, what is the relevance of the number 9 or 9 ticks?
Oh, well, because there's only 9 possible cells in the tic-tac-toe board.
Okay, so there is importance to that. It's not like we just chose a random.
And yeah, it's not arbitrary.
Definitely.
Yeah, so then we're going to iterate through this 9, 10. Well, I mean, hopefully there's a break in there somewhere, because you could win the game before 9 turns, but let's see what happens next. So on the first iteration, iteration 0, it prints the board, and then it prints turn 4, and then the variable turn, which we previously assigned the value x on line 14. So it's turn for x. What space do you want to place your x? And then on 18, we prompt the user for what space they want to choose and assign it to the variable move. And then on line 19, what's to say, the board. Okay, so the dictionary, we're asking. So then the user has to know the key, I guess, it's drawn on the board, my bad. So that they can know what the key is. So if they wanted top left, they would type top dash capital L. So when on line 8, well, or more specifically, because we're looking at the dictionary on line 2, it's the key.
Good point.
So then so 18 we prompt for input, 19 we take that input and use the user's input as a key for the dictionary, and assign. What's happening there?
Okay.
Oh yeah. So because turn was set to x, we're setting that value for that key to x.
Got it.
Yeah, to symbolize that that's where the user wants to put their x.
Mm-hmm.
And then 20 and 21 is a toggle. So if turn is x, and make it, I'm sorry, 20 to 23 is a toggle. So if turn is x, make it 0. Otherwise, x, because it was an x already. And then, it doesn't go to 25. It goes back up to line 15 for the second iteration where I equals 1, and repeats until it goes all the way to 8, and then we have a completed board. So it's not checking to see if somebody wins the game at all, it seems.
Mm-hmm.
Yeah, this is just the initial thing.
It's pretty basic, it looks like. So let's go see that baby in action. So it's defining everything. Wait.
There's the call to the board, to print the board, because it jumped back up there. So it's printing the board.
It's very pretty.
Yeah.
You can sort of see it, right?
Yeah. ASCII-tastic.
Okay, so now we're getting to the good stuff. We got our board printed. So now it's about to ask us a question.
Yeah. So
for x, which we have to move on a space. So this is where you actually have to know the way it's written. So where should I go?
Middle.
Center
square.
That's real.
Or not, wait, 1, 2, 3, 5. Do 5.
Huh? No, okay. I'm writing in mid-5. The reason I'm writing this is because it's using a key.
Oh yeah, mid-M, right?
Yeah.
Yeah.
We have to use however it was written up here in the dictionary. So we're gonna, this first round, let's act like we know all the information we possibly can. Okay, so we're gonna throw a submit in there. And let's see. Wait, did it print it?
No. Did you hit enter after you typed mid-M?
I did. Let's try it again.
Yeah.
Wait, I'm going too far.
It draws forward.
Mid.
And then we get the prompt.
In. And then I submit that. Huh.
Oh, we don't have code to actually place an X in the drawing. Oh, well, it's on the next call. It should print the next call to print the board. We should see it.
Yeah.
Yeah, through.
Oh, I didn't get that far. Okay, sorry guys. There we go. So we did mid-M. Okay, so then we keep going. And now it's asking us for O. Wait, I don't know the appropriate ones. I'm just throwing one in here.
Eeny, meeny, miny, mo.
And there's no error checking, so if we type the key wrong, it would error out, I guess.
Yeah, explode like a dead dog on the highway.
Actually, I actually tried that. It's not going to explode. It's very sad.
Oh man, I live for explosions.
No explosion. Sorry.
Just to warn you, Jamila, there's two, at least two, if not three, confessed QA people here. We like to break things. It's only fun if you make it explode.
I love it. I am a QA at heart. I love it. Okay, so this is if you're doing everything according to plan. It'll slowly but surely keep going. But because there is no handling of anything fun, what happens the next time we do this? Let's say, what did you say? I think you wanted us to put it in position 5, right?
Yep.
Okay. Let's add 5 and see what happens. And notice, all it does is repeat 5 and just keeps going on with life.
Ah, nice. It just ignores you. I don't like that. That's mean. What a reaction.
And it just keeps going. So basically, it's just going to keep doing this, even if I put nothing in there.
That's interesting. It won't let us break it.
Well, not in that way. I mean, it's still broken. It's just not, you know, it doesn't have a juicy stack trace. This is actually a worse kind of bug, right? It's the one that silently farts.
Yeah,
and then you wonder why, like, the whole machine falls over because the memory is full. Yeah, one of those.
So that's the unfortunate part about all of this. If we didn't put any error handling in there, it just lets us keep going. But it will eventually stop because that for loop has an ending.
And you only have 9 slots to fill, and even if you don't fill them,
it'll stop. Yeah.
So very, very, very basic tic-tac-toe board. But what I love about this example is it gives you an idea of, okay, so this is how a data structure, something as simple as, or a data type of dictionaries actually translates to something seemingly real world. We have to just mark the positions and sort of associate every position with a key value pair in a dictionary, and we're able to sort of build this concept out of a tic-tac-toe board. That's really cool, I think. Now, that's all tic-tac-toe. You know what? I haven't been paying attention to the chat. There hasn't been any conversation, has there? And over there. Okay.
We got 9 boxes.
Angelica reminding us that there's only 9 boxes in a tic-tac-toe board.
Yes, that's why we have the 9. Awesome. Okay, so I did want to mention for anyone who was interested in making like a tic-tac-toe board that made sense, there actually is source code for the complete tic-tac-toe program. So if you go to this link here, it asks you to buy the book. Just ignore that part. And go here to additional online resources, specifically on chapter 5. And it gives you everything to actually say like who the winner is. And it walks you through how to...
I love this. Look at this flowchart. It's like,
Let's talk about how it's designed. Yeah. Oh, look at that. 5. I wonder. So then by the end, you actually are keeping track of the winners and stuff like that. So, so if you really want to get into that, we have that available here on the internet.
We also, if you go to the Women Who Code Python repo under Beginner Nights, I did a variant of this very same tic-tac-toe program. And I have, there's a repo there. There's a bunch of warm-up exercises. There's also 2 flavors. So there's one flavor where you do it on the command line, and there's another flavor that uses the turtle to draw the board for you so that you can play against the computer and have the computer, you know, you challenge the computer and see if you can win against the computer or not.
Oh, I love it. Yeah. Do you mind putting that link in Slack?
Sure.
So that we can keep track of that. Okay, next conversation is all about, what time is it? How long have we been talking?
It is about, let's see, 9:21 Eastern, so 6:21 Pacific. So we're about a half an hour, I think, over, or 20 minutes over. Is that right, or did you set this for 2 hours?
I set it for 2 hours.
Ah, okay. So we've got 40 minutes left,
Thank you.
give or take.
My brain is just totally fried at the moment.
Yours and mine both. I'm like, la la today.
Okay. So our next little piece that we've got going on here is nesting dictionaries together.
Ooh, Inception. It's dictionaries all the way down, people.
Okay, so if you look at this example, this is basically keeping track of, okay, so we have these guests that are coming probably to a picnic, and they're bringing some items, and we're going to add up how many total items were brought. So for example, we have a dictionary of guests first. So we have Alice as a key, Bob as a key, Carol as a key. But Alice specifically brought some things. So she has her own dictionary. So she has apples and pretzels. And Bob has ham sandwiches and apples. And Carol has cups and apple pies. Now you'll notice at least 2 people brought the same thing. So Alice and Bob both brought apples. So how many total apples do we have? That's what this code is basically doing, is keeping track of all the people and then adding it all together and then outputting in total across all the individuals, how many items do we have? So that's the code that we have here. And anyone want to walk us through this piece? Any volunteers? Okay, then what we've got here is we're going to start off with our dictionary that we see here at the top. And then we're defining a function that's tracking how many items were brought by person. So if you'll notice that what we're pulling in first is the dictionary of all of the guests, and then we're going to keep track of the specific items for each of those guests. Now, we start off with the number brought was 0. And what we're going to do is we're going to go through this dictionary of guests, and we use this fun function that we have called items. And items is going to go through, let's see, if I remember correctly, items is a function, or a method, rather. It's different than key, and it's different than values. Keys gave us a list of keys. Values gave us a list of values. Items will give us the list of key, comma, values. So we're gonna bring back 2 pieces of information. And this is the part that I always get thrown on, which is actually probably where the meat of this is. So I've got to break this down. Okay, so V. What was V?
So items is a list of tuples, correct?
Tuples? Oh,
yeah,
yes, they're tuples.
They're tuples. So tuples, they're tuples that have what in them? There's 2 things inside each tuple, right?
The key and the value. In this case, because of items.
Yeah.
So in duh. K probably stands for key. V probably stands for value.
And this is exactly why, a lot of people say that it's fine to use single letters for variable names in when you're doing loops like this. But for me personally, this is why I always spell it out with key and value, because it's just really hard to track for me. So yeah, it's the key, because that's in position 1 in the tuple, and then the value.
So keeping that in mind then, this value here, okay, so what I must be doing is it's going to the value of, okay, so if it passed in guests, which is Alice, Bob, and Carol, it's going to the value for Alice, Bob, and Carol, so that's this dictionary.
Yep.
it's pulling the item of apples is 5. And taking that 5 and adding it to the number brought. I feel like I'm missing a piece. Like, how did it know to give it to apples?
I think it's because it's the second argument for item. We're saying we're looking for the string value apples. So it'll go through the second dictionary, the inner dictionary, and look for that string. And
oh!
Yeah, there's 2 here.
I see what you're saying. Okay, so like right here, if we go to this call, it's passing in the dictionary, but then it's passing in the string for apples. So that's what you're referring to. It came in as item. It's looking specifically for apples. It's getting the value at apples and assigning it. Gotcha. Okay, cool. And so then it keeps adding it to that number. And then it prints.
correct.
Number of things goes to that function, does that math, and then that's the number it prints. Then it goes to the next function specifically for cups, calculates how many cups, it returns that number, on and so forth. Okay, cool.
So just to one last portion, I guess,
Yep,
is that
yep.
When we go through this, that for loop,
Mm-hmm.
the way I look at it is it'll go through each and every one of those key value pairs on the outside dictionary being Alice and what she brought, Bob and what she brought, and Carol and what she brought, not just Alice or not just Bob or not just Carol.
So it went through 3 times basically, or however many is in the guest list. But
Correct.
in this case, it went through 3 times. Looked at all of Alice's stuff for apples, look at all of Bob's, Carol's, gotcha. Okay. And if we look, please tell me I have that here. Yes, I do. And see how that plays out for us. If we're looking at the number of items brought for apples, so it's going to print out apples and then the number. So if we look for this next one, it called total brought all guests in cups. It passes in all guests in cups. And it goes and sees, is apples cups? No. Ham sandwiches cups? Or is this dictionary cups? No. Does this dictionary have it? Yes, there's 3 there. So we should see number brought go up from 0 to and increase to 3. And there we go. And 3 is returned back to this line for printing. And now we have cups is 3. And then it just goes through all of them, similar to that. So that's a really fun exercise. It's that particular line just requires a little breakdown for me personally. Does anyone have any? Oh, someone's going to say something?
Yeah, my question is, this is, I think, on Bethany. Bethany, do you think we can use the collections library here?
Do I think that they use the collections library here?
I mean, can we use that and utilize it for this particular example?
You should be able to. What in collections would you use here? Oh, the counter. Yeah.
Oh, that one line nonsense that you taught us last week. We were all like blown away. Like, we wrote all this code.
Oh, that's awesome. You know what? Let me try a quick test because my brain is kind of half frozen. So let me paste this code into Python Tutor myself. But I think, Kevin, you are on the right track. I think that, yes, collections might shorten this considerably. We might be able to perform one-line nonsense on this. I like that. That is going to be my new name for this. When I mentor people, I'm gonna say, you can use this one-line nonsense right here.
I probably should not have said that on a recording. This is not nonsense. This is valid, valid coding, beautiful professional work going on right now.
No, it is kind of mind-boggling how much shorter using a counter is. And nonsense is a good word for it because it doesn't feel very intuitive.
But it just takes all of that, when you learn it the long way, and then eventually you're able to use the shortcuts, and you can see all the magic that happens when you understand that. Those
I've had people tell other people when they figure out like a library actually does this whole big thing instead of like this 50-line piece of code. It's like, do you have a lot of spare time, or were you drunk when you were writing this? Because there's a library that will do that for you.
I feel like that's like going to be a special segment we need to have. Shortcuts, those things that you do the long way. There's a library for that.
There's a library for that. Yes. Sometimes too, I hate to say, but as I think Kevin is pointing out, I do some mentoring on a site where that encourages people to learn additional programming languages beyond, maybe the first one or two that they know. And I mentor a little on the Python track for this site, and you'll see people who clearly have a background in Java or in C or C++ or another language that wasn't made by people quite as lazy as the makers of Python is maybe the best way to put it. Python has a lot of methods of convenience, right? A lot of ways of shortening things. And so it sometimes is a little bit heartbreaking because you'll see a C programmer very, very carefully like write out a manual sort to do something and then do something else. And you're like, that's beautiful. It is, it's beautiful. But that's one line in Python, right? And then they'll come back and be like, no, it's more performant my way. And I'm like, no, actually, no. But that's okay.
Way to crush their hopes and dreams.
Oh, it's so hard. You actually, what you want to say is you solved the problem and you solved it well, but there's this other way to do it also. You don't want to say, were you drunk? Because even if you think it, it's not nice. All right, let me see if I can make this a piece of one-line nonsense. I may not be able to.
And while you're doing that, I'm going to go ahead and finish our last practice project that we have is the fantasy game inventory.
Ooh, yes.
Okay. That's going to be real interesting. We have 2 versions of it. So I'm going to jump to the second version of it just because it incorporates the first version as well. So what we're doing is essentially we're keeping track of, like, if we were in a game and we were collecting all these items, that's great. But I want to, at the end of the day, I want to see how many items I have. So we list out specifically arrows, gold coins, and rope, how much we have. But then in total, across every single one of those values, how many do we have? So we get a really fun exercise in for loops and dictionaries. Now, did anyone want to share their code for this? And we can walk through it? Because he didn't give us the code for it. So you had to work on it a little bit yourself. Anyone want to share what they have?
Oh, a bunch of shy people.
Okay. Okay. My last one did not work, so that's what y'all are gonna get, is my half working code. So this first portion is just trying to print off what you have, but this second portion of it, it's actually trying to keep track of some dragon loot as well, and so it adds that to our existing inventory. So let's see what we got up here. Nope, that's Fancy Feast. That's not the one we want. So what I have here is I created a satchel that has things in it. And I'm pretty sure these are not the things that he mentioned. I just was writing it myself. So I have a satchel that has some stuff in it. And I want to display that information. So what I did was I created this display inventory function, and I'm passing in the dictionary of a satchel that has things in it and how many of those things there are. And I'm sure there is a simpler way of doing this, but this is just how I had to do it to make my mind work. I had to keep track of how many things were in my satchel. So I went ahead and printed that very first line. Here's my inventory. I passed in the dictionary that came through this function called inventory satchel, and I pulled the items, very similar to what we did in that previous example. And since it gives me a tuple of keys and values, I actually changed it from K and V to key and value so I could keep track of what that meant. And then I just printed the value with a space and then the key. Now notice I had to convert it to a string. Like I couldn't just say value plus space plus key, because when you're using this little plus sign, that only works with strings. So I had to come back and add the str on the front to convert it to a string. And then whatever that number was, like 2 swords, I added that to the total and I printed it. Did I do something wrong? I'm already looking this over and I'm wondering if I did something wrong.
Let's try it.
Because I just realized I probably did something wrong. Okay, yeah, let's try it and see. Okay. Okay, so it starts off by creating a dictionary. There's 1 sword, nope, 1 bag, 2 swords, 5 boots, and 1 flute. So the total comes in as 0. Prints off inventory. The key is bag, and the value is 1. So 1 bag got printed. The total ends up being 1. I messed this up, didn't I? Okay, so it went to the next thing. So our sword has 2 things in it, and it printed off 2 swords. And that's what I was worried about. But now my total is 3. Oh, that's right. That's what I want it to do, because my total is supposed to be the overall total, like how many things across all of the items. So it's slowly adding it up for each one. So maybe this will actually work. So it has 5 boots. So we add 5 boots to the 3, so we have 8. Now we have 1 flute, so we hopefully have 9 things. Total item is 9. And that's it. I guess the best way to test it is to see if it still works with some other numbers. $93. So that's what, 72, 83, 93? Okay, it looks like it's working. Any questions or comments about that? Do you see a way to make it simpler?
I was going to try something, but my editor is actually, I had to reformat my computer, so I don't have my editor handy.
Oh dear.
I was going to say, why can't we pull the, just like, what was it, item satchel.values and just get the sum of the total? Is that possible?
Wait, take inventory satchel.values. Is that what I heard?
Yeah, isn't there a way for us just to pull the values of it and just get the sum of it?
Okay.
If the purpose is just to pull all of the sum total of just everything without being picky as to which particular kinds of items we're supposed to be pulling, I wonder if that's possible.
So, if I remember correctly, that will return a list dot values. So would that be a dot length maybe? Wait, no. Because that's just counting the number of things. It's not actually adding them together.
Yes, so let's try this. So where it says, hold on, let me do a full screen here. So where it said in the first part before it says inventory satchel, put in a sum. Oh no, you can leave it there. Yep, and then where it says inventory, put sum, S-U-M, and then opening parentheses and the ending parentheses in the very end.
And that's it?
Let's try that. Unsupported values, because I'm pretty sure there's a way for us to use sum in here.
Oh, sorry, that's just me not completing my thought there.
Oh, I think I know why it's not going to work in this case, at least because it's a string, right? Unless we we turn that in just to a plain number, then it'll get the sum of everything. Because on the, we have a for loop that turns the value into a string. So what I would do is I would comment out the for loop between line 7 to line 9.
Well, we still need to print. We still have to print the value for each one.
Oh, so we're still trying to, okay, so yeah,
Yeah,
then I guess,
that's part of the for loop.
okay.
Now after the for loop, we can do something. Like that's what line 11 is outside of the for loop. So once everything is said and done, we can try to print just the sum of inventory. And I took it out of the string that I was doing before.
Okay, we could try that.
There we go, 93. Oh, that's cool.
Yeah, it's another one-line nonsense.
So
and that is the title of our new webinar.
Yeah.
Hosted by us three. One-line nonsense. I like that. I'm still working on my one-line nonsense, by the way. I'm almost done.
Yes, do not mistake one-line nonsense for ease of like coming up with it. You have to probably work at it. But then it's very simple when you write it all out. Okay, okay, so that's our inventory one. We got 15 minutes left. Now, before we look at that very last one, I wanted to go ahead and pose this because people might be disappearing on me. Next week. So normally we do this event every single week, and I just wanted to get everybody's input before everyone goes away. If y'all would be okay with us taking a break for a week, and then we come back and do it every other week. So what is this, September? So for the very first week in September, we just take a break, and then after that, we do it weekly for the rest of September. How does everyone feel about that? It just gives everyone, because I know that we've been using Everybody's Thursday pretty consistently for like all the summer. Just wondering if anyone has any particular opinions. Basically, take next week off, and then we'll finish off, we'll do it weekly after next week. So my thought was maybe 1 week every month, we just take a week off. Any yes? I have one yes, and I have no other responses.
um,
Now, on that week off, yes, it gives us time to catch up. Okay, that was our thought. We have some options, like with that 1 week off. You can catch up on your own. I can like put up a recording, I think. I've heard people can put up recordings, so I can throw up a recording that we have from a previous week. That way, if someone wants to watch it, we can. But at least just 1 week each month to let everybody breathe, catch up, anything like that. So my plan is to do that next week. And if anyone has anything to say about that, like no, please let me know in chat or in Slack before we make that official starting on Monday. Okay, that was the one thing I wanted to ask. Second thing I wanted to ask before we finish up is, would anybody, from a homework perspective, if we're looking at chapter 6, because that's what we're going to start when we start in September, not next week, the 3rd, but the week after that. If we're looking here in chapter 6, we're going to start manipulating strings. And remember, we were going to break everything up so that we don't do a whole chapter in a week. We're going to try to do like one chapter over the span of at least 2 weeks. So if you're trying to keep track of your homework for the next class, we're going to start on chapter 6. Notice that there are some videos here, so you're welcome to look at those videos to help you out. But my thought was we can get through maybe that first week, all of these fun little functions. And this is when, remember how we were having that conversation about stripping strings and right string versus left string or something like that? That's all of, here we go. I think that's what we did in one of our previous lessons, right strip versus left strip, removing the white space from strings. That's what we're going to go over in chapter 6. So it's going to be really fun. But when you're done with that, once you're done with the reading, there's also a project for password locker. We create a password locker. We also have a project for adding bullets. And then we have another project down here for printing the tables. So we got a lot of stuff in chapter 6. My thought was, let's get through the reading and get through all of the reading right up to here. Basically, as soon as the projects start, let's hold that for the next week. Okay, so we're not going to do any of the projects. What we will do is focus on the reading, and your homework is to be able to answer these questions in chapter 6. These practice questions. That's all we're going to do for that first week in September. Cool? Yay, silence means yes.
I'm cool. I want to make sure everybody else lists a preference, so.
Okay, I'm seeing some thumbs up in the chat. Awesome, guys. So that's all we're going to do. We're going to do the reading and the practice questions for, what's my calendar say? Does anyone have a calendar in front of them? It's not next Thursday, it's the week after that. I think it's the 10th, maybe?
Let's see. Sorry, I have to change my calendar reading.
12th. Okay. Thank you, Angelica. Appreciate it. So we'll meet back here on the 12th, and we'll do chapter 6, just the reading part, not any of the practice projects. We'll hold that for the week after. And what I'd like is for one person to volunteer to help us review the practice questions. So you're responsible for making sure we have answers for all these, and you can walk us through these practice questions. Does anyone want to take that on? It's sort of like a little personal homework challenge to make sure that you do the work before next class. Anybody? Don't all say yes at once. Okay, yay. So all you're doing, so Angelica has volunteered. Thank you, Angelica. All you're doing is for the practice questions, just have an answer for every single one of these so that when we come to this portion and we ask everybody, what are the escape characters, you can help us answer that question. Cool? That's all we're looking for. I'm trying to figure out other ways people can get involved in the study session. So if you feel like you need some like homework, personal homework, to just make sure you keep on track with everything, that's my goal, is to get people involved in any way that they feel comfortable doing. So if you can think of something that you want to do, like take notes, or always make sure that you have one of the coding practices ready, please let me know. Take in volunteers. Otherwise, you'll hear my voice all day long, and that gets pretty boring.
We like listening to you. You have a lovely voice.
So with that, I think we got 8 minutes left. I don't know if we can finish this last bit of this last project in 8 minutes or not, but I can try. I just wanted to make sure that was out there before people disappeared, that we got that wrapped up. Okay, the last thing they want us to do with this very last practice project. So we do all the same stuff that we did before. Uh-oh, this one. We print inventory of gold coins, ropes, rubies, and daggers, but we have to add to our inventory. There's like this little piece here where we have to add a function that's called add to inventory. Basically all this dragon loot. And what's different, so you see how this dictionary shows the golden coin has 42 and the rope has 1? What's different about this dragon loot is it's listed out as a string. So you have to somehow match golden coin to that, and golden coin to that, and golden coin to that. So for this one, I think, did anyone get this code done by chance? Because if not, I think that we should make that homework for next time. See if you can use the code that we went over today, and see if you can try to add the little piece of being able to add to inventory. Because otherwise we might be sitting here for probably another 15 minutes working on it together. So if everyone can try to do that, this last little code piece, we can review dictionaries just one more time before we jump into strings next time. Okay, so that's our homework. Will you put it in GitHub? Yes, I can put it in GitHub. That's why I have all of these tabs still open. It's because I'm trying to hold on to the code so we can get it added to GitHub. Not only the ones that we went over, but the fantasy inventory, which was just the one that we did today. Come on. Right here, this guy. I'll get that added into inventory so you have a starting place to go. Can you share your GitHub? Yes. In Slack, we'll post the GitHub there in Slack for everybody, just because this chat won't live on forever. But we'll post the GitHub there, and we'll let you know when the code gets added to the GitHub in Slack. Sound good? Awesome. Well, thank you guys so much for coming.
Thank you for hosting. Wonderful as usual. And I'm still working on that one-line wonder, but when I get it done, it'll go on GitHub with the rest of it. So.
Yes, we will have one-line wonders. I think we need to have one every single time. Just one
challenge accepted. We'll have to have a.
That's a tall order, but yeah, we can try.
Oh my gosh, I feel like between the two of y'all will figure something out. Okay, well, thank you guys so much. We really do appreciate it. Have a wonderful evening.
You too.
Good night, y'all.
Good night, night. Bye.